All right, I'm going to be working homework problems here for using the formulas for differentiation for taking derivatives, basic differentiation properties, section 10.5. And I'll be starting here with number 9. And we're being asked to find f prime of x for the given function f of x equals 7. So what we are going to use here is the fact that we know that the derivative of any constant is always 0. So the answer to this is just 0. So if you just have a number by itself, the derivative is always 0. So 9, very straightforward. Number 11. We want to find dy dx for y is equal to x to the 9th. Now, dy dx is another notation we use that means find the derivative. And so we want to find the derivative of x to a power. And for this, we're going to use the power rule, which says that the derivative is equal to, the power will come down in front, 9, x, and then we subtract 1 from the power. 9 minus 1 is 8, so we get 9x to the 8th power. And that's it. We're done. Number 13, some of the notation changes here. We want d dx of x to the 3rd. So this again means take the derivative, treating x as our variable, of x cubed. So this is the same as this problem, just using slightly different notation. I'm going to use the power rule here. So the 3 is going to come out front, and then I'm going to subtract 1 from 3. 3 minus 1 is 2, so 3x squared. 15. Find y prime for y equals x to the negative 4. Again, another notation for the derivative is y prime. Y is equal to x to the negative 4. We're going to use the power rule again. So the negative 4 comes out, and then x, and we're going to subtract 1. So be careful here. It's negative 4. We're taking away 1. Negative 4 minus 1 is negative 5. So we get negative 4x to the negative 5. So there's our answer. Now we're going to move on to number 17. So things go pretty quick here with these basic rules. Once you understand them, it makes taking derivatives much, much faster. Okay, 17. We want to find g prime of x. So that's the same as saying f prime of x, but we're using the function g. G of x is given to us to be x to the 8/3 power. So again, we have x to a power, so we're going to use the power rule. So g prime of x will be equal to, we bring the power out front, 8/3. That'll be x raised to the 8/3 minus 1. So we actually need to figure out what that is. So 8/3 x to the, let me do 8/3 and then minus, I need a common denominator. We treat this 1 right here as if it was 1 over 1. We need a common denominator of 3, so I multiply top and bottom here by 3. That's the same as 3 over 3. So that's still a 1, but now I have the same denominator. So I subtract 8 minus 3 is 5. So I have 8/3 x. I get 5 to the 5/3. So that's it for number 17. Number 19. dy dx is what we want. And they tell us that y is equal to 1 over x to the 10th power. Now we need to make sure we're careful here. We can't just say this is x to the 10th because it's in the denominator. We actually need to realize that that's x to the negative 10. So remember, negative exponents mean you drop down. So like going backwards from here, we go back to this. And now we can use the power rule. dy dx is equal to, the power comes out, negative 10. Then x to the negative 10, subtract 1, that's going to be negative 11. So negative 10 x to the negative 11 is the answer. Okay, number 21. We have f prime of x. That's what we're looking for. And they tell us that f of x is 5x squared. Now, this can be a little confusing for students because you know that the derivative of a constant by itself is 0, and the derivative of x squared, the 2 should come down. So what happens when the 5 is attached to this function through multiplication? In that case, the derivative of 5 is not 0. You actually just ignore it. You bring it down with your answer. So f prime of x is going to be equal to the 5 that's here times just the derivative of this, which means you bring the 2 down, x to the first power, because you subtract 1 from 2. So that gives you 5 times 2 times x to the first power, which is 10x. So just be careful on that. The constants that are in front of some function of x just come along for the ride. 23. Y prime, 0.4x to the 7th. We want y prime, and y equals 0.4x to the 7th. So again, 0.4 is a constant. It's attached to a power of x. So I'm just going to bring the 0.4 with me, and then take the derivative of x to the 7th. So the 7 pops out. I'm going to bring that down like this. 7, that's multiplication. And then x to the 6th, because I subtract 1 from that. And then 0.4 times 7 is 2.8 x to the 6th. So that's your derivative. Number 25. D dx, so the derivative of x cubed over 18. All right, so for this one, we need to realize that this is the same as 1/18 times x cubed. So if we were asked to put these together, this would be like over 1, and you go 1 times x cubed, which is x cubed, and you go 18 times 1, which is 18. So these mean the same thing. So I'm just sliding this x cubed out to the side, and now I realize I'm taking the derivative. I have a constant attached to this power of x, so I'm going to bring the constant down. So the answer to this is that this is 1/18 times, now just the derivative of this, so 3 comes out, and I subtract 1 from the power, and I get that. Now, this is like a 3 over 1, so you can reduce this fraction. 3 goes into 3 once, 3 goes into 18 6 times. So you should have a 1 on top, and then a 6, and then you still have that x squared out there. All right, let me see here. Now we're going to move on to 33. So for 33, we have derivative with respect to x of 2x minus 5. Derivative with respect to x of 2x minus 5. Okay, so this is the first time we've actually had two separate terms. So terms are separated by addition and subtraction. So I have a subtraction sign here, so I'm going to take derivative of these individually. So first derivative of 2x, the derivative, the way we do that is the 2 comes down, and remember this is x to the first power, and we can bring the 1 out, and then we subtract 1 from the power. 1 minus 1 is 0, so this is really 2 times 1 times x to the 0, minus, now, derivative of a constant by itself is 0. Now remember, x to the 0 is really a 1. So this is really 2 times 1, which is just 2, and then minus 0, so you just get 2. I may also point out that the derivative of x is just 1. So I could have just done that. I could have said the 2 comes down, and then derivative of x is just 1. But I went through and I showed why it's that way with the power rule. All right, so the answer there was 2. Let's look at number 35. find f prime of t if they give you that f of t is t squared, 2t squared minus 3t plus 1. 2t squared minus 3t plus 1. This time we have three terms. We've got this, this, and this. So I'm going to take derivative of each one individually. F prime of t. Okay, so here we got 2 times some function here. So I'm just going to bring the 2 down. Now, derivative of t squared, 2 comes out front. I reduce the power by 1, and I just get 2 minus 1 is 1. Then I have minus, let's do this one this way. The 3 comes down, times the derivative of t, which is just 1. That's like the derivative of x is 1. And then plus, so that's the plus, and then derivative of derivative of a constant is 0. So all you're left with here is 2 times 2, which is 4, then times t, so 4t, and then minus 3 plus 0. So it's just 4t minus 3. All right, let's do number 30. What are we doing? 37. So we want to find y prime, and they give us that y equals 5x to the negative 2 plus 9x to the negative 1. Okay, we want to be a little careful here. The derivative is, okay, I have 2 terms here, right? This one and this one. There's a plus sign between them. So the 5 is attached, so it's going to come for the ride. Now, power rule on this piece right here. Negative 2 comes out, then x to the, well, you have to subtract 1 from negative 2. Negative 2 minus 1 is negative 3, so that you got to be careful with that. Then I have plus. Now here the 9 is attached, so I'm going to bring it along and then take derivative of this. So negative 1 pops out of that. X to the negative 2, again, because I'm subtracting 1 from negative 1. So negative 1 minus 1 is negative 2. So we've got that. So if I clean this up a little bit, 5 times negative 2 is negative 10. X to the negative 3. And then plus, let's see, 9 times negative 1, that's minus 9. Then x to the negative 2. So there's that derivative. Moving right along. Going along to number 41. Okay, number 41. I want h prime of t. And they give you that h of t is 2.1 plus 0.5t, and then minus 1.1 t cubed. All right, we have 3 terms, 1, 2, 3, so I'm going to take derivative of each one separately. This is a constant by itself. There's no variable with it, so derivative of constant is 0. Plus, now I have a constant attached to a function. So I bring the constant down, 0.5, then take derivative of t, which is just 1. Minus, now I have a constant attached to a function, so I bring it down, 1.1, and then I take derivative of t cubed. That's going to be 3 comes out front, t squared, because the power comes down by 1. So I have to do 1.1 times 3, here I have to do 0.5 times 1, and then of course we get 0 out there. So all I'm left with is this, which is just 0.5. And then when you multiply 1.1 times 3, you get minus 3.3, and then t squared, that last piece. So that's 41. Number 43. Find y prime if y is equal to 2 over 5x to the 4th. All right, this one's a little tricky. First, let's realize that this is the same as 2 over 5 times 1 over x to the 4th. So that x to the 4th and 5 can be split up into 2 pieces like this. So if you multiply straight across, you get this. But this helps us because I can rewrite this as 2/5 x to the negative 4. So I can use this right here, bring this up and use a negative exponent. And now I can take the derivative. So my derivative is going to be, well, the 2/5 comes for the ride. And then I bring the negative 4 out. X to the negative 5, because I subtract 1 from negative 4, I get negative 5. And now I'm going to multiply these two together. That's like a negative 4 over 1, so just straight across. You get negative 8 over 5, and then x to the negative 5. Next one is number 45. I want the derivative with respect to x of 3x squared over 2 minus 7 over 5x squared. All right, so for this one, I'm going to do kind of the same thing. First, let me rewrite. I'm not taking the derivative yet. Let me just rewrite some stuff. This first one is the same as 3/2 x squared. And this one is kind of like the one we just did right here. It's the same as minus 7/5 x to the negative 2, because this x squared down here comes up as an x to the negative 2. Now I take derivative of each one of these separately because I have two terms, so I'm ready to take derivative. No more d dx here. This is a constant attached to a function, so 3/2 comes for the ride, times now this. That's just 2x to the first power. And then minus 7/5 comes for the ride. Take derivative of this. You've got a negative 2 there, x to the negative 3. Again, subtracting 1 from negative 2 gives you negative 3. And now, these 2's actually cancel. You're just left with 3x. Over here, nothing cancels, so I just have to multiply straight across. I get a negative 14, but then it's subtracted, so it's going to become plus 14 over 1 times 5 is 5, then x to the negative 3. So that's it for that. Number 47. They give you capital G prime of W is what we want. And they give you that G of W, capital G of W, is the function 5 over 9W to the 4th plus 5 cube root of W. 5 times the cube root of W. Okay, I want to clean this up first. This is going to be 5/9 W to the negative 4. We've done that before, 5/9, and then bring the W to the 4th up. This is a little tricky. Plus 5. Now this is the same as W to the 1/3 power. So we're using the fact that if you take the nth root of x, that's x to the 1 over n. So if we do the 3rd root of W, it's the same as W to the 1/3. And now we should be able to take our derivative, G prime W, should be equal to, all right, so constant attached to this comes for the ride, times the negative 4 comes out, W to the negative 5, so subtracting 1 from negative 4. Here plus 5 comes for the ride, 1/3 comes out, W to the 1/3 minus 1. And we have to get a common denominator there. 1/3 minus 1 is this. 1/3 minus 3/3. So this becomes 1 minus 3 over 3, which becomes negative 2/3. So when I do this, this becomes negative 2/3. Let me go ahead and just do that. So yeah, okay, that'll work. Let me just clean up. Here times here, that's like a 1 on the bottom there. You can get negative 20 over 9. W to the negative 5. Here you multiply those two, you just get 5/3. and then w to the negative 2/3. It's ugly, but that's it. All right, 49. Yeah. d du, so the derivative, treating u as our variable, of 3u to the 2/3 minus 5u to the 1/3. All right, so I think I can just go right now and do this. Two terms, I've got a constant attached, it's coming for the ride. I've got a constant attached, it's coming for the ride. So I've got the 3 here times, now here I use power rule. So 2/3 comes out, 2/3 u, and then I have to do 2/3 minus 1. I'll do that on the next step. And then I have minus 5 times 1/3 comes out, u to the 1/3 minus 1. Okay, so let me do these two computations real quick. 2/3 minus 1 is the same as 2/3 minus 3/3, which is negative 1/3. And then 1/3 minus 1 is the same as 1/3 minus 3/3, which is negative 2/3. So I've got those cleaned up. These 3's cancel, and I'm just left with 2u, and 2/3 minus 1 was negative 1/3. And then here, that doesn't clean up. That's just going to be minus 5/3, and then u to the negative 2/3. That's it. Okay, moving along to number 77. If we're trying to find f prime of x, and we're given that f of x is equal to 2x minus 1 squared. All right, so the difference in this problem is that, yes, we do have two terms. We should be able to do them individually, except for the fact that it's squared. So you cannot do them individually because of the squared part. So what I'm going to do is I'm actually going to square that. I'll take 2x minus 1 times 2x minus 1. That's what it means. And I'm going to FOIL. So when you FOIL this, you should get 4x squared minus 2x plus 1. And that's just 4x squared minus 4x plus 1. So I'm trusting that you can do this FOIL and get this. And now I just need to take derivative of this. See, there's no more squared. I've already taken care of it. So if I take derivative of this, I can just do each one of these individually. So let's see if we can move a little faster now. Derivative of this, the 4 comes for the ride. The 2 comes down, so that's going to be 8x to the first power. Here, negative 4 comes for the ride, and the derivative of x is 1. And then plus the derivative of 1, which is 0. So I would be adding a 0 out here. Don't need to do it. So that's it. 8x minus 4. And the last one, derivative with respect to x, number 79. We want the derivative with respect to x of 10x plus 20 over x. So here we have division, and this is going to be a little tricky. We cannot just take the derivative here, here, here. Cannot do that. Our best hope for this problem right here is to split it up into two fractions. So do this over this plus this over this. Now we have two terms. I still haven't taken the derivative yet. But these x's cancel, so I just have 10. And this one right here, watch how I write this. 20x to the negative 1. See, I'm going to bring the x up as a negative exponent, x to a negative exponent, and leave the 20 out front. Now I can do these individually. So the derivative of 10, that's a constant by itself, is 0. Plus, 20 is coming for the ride because it's attached. So 20, and then derivative of this, the negative 1 comes out. X to the negative 2 because I'm subtracting, And this just gives me, what, negative 20 here? X to the negative 2. All right, that's it for that homework. That was very computational, but I hope straightforward.